Imagine you launch a spaceship from Earth, pointing it in a perfectly straight line, and you just keep the engines firing forever. Would you eventually loop back around to where you started? Would you crash into some kind of physical barrier at the edge of reality? Or would you simply drift through empty space for eternity? Curious. Solving this starts with a question that seems too simple to be a mystery. Why is the night sky dark? It's a problem known as Olbers Paradox. If space goes on forever and is eternally filled with stars, then no matter which direction you look, your line of sight should eventually land on a sun. If you extrapolate that out, those distant stars would fill in every gap. Our night sky would be a solid, blinding sheet of light, as bright as the surface of the sun. We obviously don't see that. We see blackness. This everyday darkness is physical proof that our view of the universe has a hard, measurable limit. About 13.8 billion years ago, the universe began expanding from an incredibly hot, dense state. Space itself has been stretching ever since. Because space is stretching, distant galaxies are being carried away from Earth at massive speeds. As these galaxies race away, their movement physically stretches the light waves they emit, shifting them toward the red end of the spectrum. Eventually, this light stretches so far it drops into the infrared spectrum, where our human eyes simply cannot see it. Cosmic expansion acts as a massive cloaking mechanism, hiding the blinding light of the infinite universe from our vision, leaving our night sky dark. Space is expanding uniformly in all directions. This creates a specific distance where the gap between us and distant space is growing faster than the speed of light. This creates the Hubble Sphere around Earth. Light outside it acts like a swimmer fighting a rapid river. Over time, some light crosses into our reach, forming our Observable Universe, a sphere 93 billion light-years wide, holding everything we can detect. This is the absolute limit of human observation. No matter how powerful our technology becomes, we will never see anything beyond this boundary. Because we are locked inside this observational bubble, we have to use the physical geometry of the space we can see to deduce what exists beyond. For thousands of years, philosophers like Aristotle naturally assumed the universe was a gigantic, self-contained physical sphere. Albert Einstein changed our perspective with general relativity, revealing that space is a physical fabric that can bend, warp, and hold an overarching shape. This meant the entire universe could take one of three shapes. It could be positively curved, like a sphere, negatively curved, like a saddle, or it could be perfectly flat. To test this, astronomers map giant triangles across the cosmos, measuring your angles against the oldest light in existence. In a curved universe, the three angles would not equal 180 degrees, but our measurements show these cosmic triangles are perfect. Spacetime is physically flat and does not curve back on itself, meaning there is no geometric border to contain it. Because the universe is flat and borderless, it is most likely truly infinite. This creates a bizarre statistical paradox. Matter within our universe can only be arranged in a finite number of combinations. If you take finite particle arrangements and scatter them across an infinite amount of space, physics dictates those exact arrangements must eventually repeat. Unimaginable distances away, there are exact copies of Earth and an exact copy of you watching this video. Our reality is a boundless flat grid, where every possible variation of existence plays out endlessly, forever out of reach. While the greater universe stretches out infinitely, our personal window into it is slowly shutting. Accelerating expansion is currently pushing thousands of stars beyond our event horizon every second. In 2 trillion years, the acceleration will have pushed every other galaxy so far away that they fade from view entirely. Future civilizations born on Earth would see only a vast, empty void. They would be totally unaware that the Big Bang or the infinite universe ever existed. We may never reach the edge of the cosmos, but we happen to live in a rare, fleeting era where we can still look into the darkness and comprehend the infinite scope of our home.